How you got the name science? Science originated from a Latin word called as scientia. So physics has come from a word called as fusus. Since fusus is a Greek word, and from that Greek word we have got the name as physics. Four fundamental forces, that is gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Hello everyone, I am Brinda, Faculty of Physics, welcoming you all to session 1 of chapter 1, and chapter name is Physical World. This comes in your first textbook. Chapter is Physical World. So what is this physical world? World is really physical? Okay, you're studying certain things. The study of behavior of non-living things comes under this physics. Okay, so as you all know, science. What is this science? Why do we call a subject as science? Okay, here in the science, there is something which here you have to know, right? Okay, science, there is something which you have to know regarding things which is going on around you, okay? You have got seasonal changes, sun is rising, sun is setting, rainbows. So the objects around us, a table, chair, and we walk on the floor, okay? We walk on the road, bus, vehicles, many other objects. We completely study the behavior, internal behavior, complete mechanism, internal behavior of a non-living objects. So that is the thing, like we need to know something, okay? So that know, the knowledge, that is known as science, okay? Science means, the meaning of science is to know, okay? To understand. I need to know why a table is still over here. I need to know why Earth is revolving. I need to know why Earth is rotating. Okay? I need to know why the speed of a vehicle or a speed of object is so and so. I need to know regarding the gravitational field. The to know is there, no? That is your science. Science is nothing but to know. This word itself is an interesting fact. Okay, to know. We need to know many things. So there are many interesting things around the world, around us, in order for us to know. Okay, so this word science, how did it originate? How you got the name science? Science originated from a Latin word called as scientia. Okay, so it has got its origin from a Latin word. Okay, that is scientia. Next, the Sanskrit word of it turned out to be Vignan. Okay, Sanskrit word of science turned out to be Vignan. Okay, then in Arabic, the word of science was called as ilm. In Arabic, it was known as ilm. So science, that is to know, originated from Latin word, that is scientia, and Sanskrit it was called as Vignan, and in Arabic it was called as ilm. Okay, so now what is this science to know? Okay, how do you know? Knowing science or knowing the operation or mechanism of certain object, you study in a systematic way. Okay, when you study an alphabet, what do? You just hold a pencil, hold a book, and you join the dotted lines in a systematic way. You don't just, if it is something dotted lines of A, what do? You just come in a systematic way. You just don't, if this is a dot, you just don't do like this and do half a way, you don't go. You proceed in a systematic way. So that systematic way is applied for all the branches, everything around the world. Okay? After 1, it is 2 and it is not the number 10. Okay? So the thing is like you will have to come in a systematic way. Similarly, it applies to the science. It is a systematic study. If you see any object passing by, you just analyze the object. Which object is that? Why did it move there? And what is the mechanism behind it? And if the theory everything is right, practically you will have to attempt it. If theory is right, you will have to give a practical thing by having a practical session, and finally you will be approving it is right or wrong. You will get to know whether your theory is right or wrong, valid or not. So that to know is nothing but science. Science is a systematic study, systematic attempt to understand the natural phenomena about the nature or about the things which is around us. So that is nothing but science. So here in this slide, you got to know what is meant by science, and the origin of science from a Latin word called as scientia. In Sanskrit it was called as Vignan, and in Arabic it was called as ilm. And science, it is a systematic study, order-wise studying, okay? Systematic study of the concepts or the natural phenomena about the nature around us, okay? To study the natural phenomena of the world, okay? So coming to one of the discoveries here, that is Nicolaus Copernicus. What did he do? He just studied regarding the space and over there planets. He told that planets revolve around the sun. Yes, planets revolve around the sun, but he told that it revolves in a circular orbit. Okay, he gave the circular orbit. So as I told you, it is a systematic study, right? When it comes like systematic study, even I can study something. My imagination, my view will be something of different kind, okay? What I view, maybe the other person won't be viewing, right? My imagination is different. His or her imagination is different. So each one's imagination regarding the natural phenomena which is taking place can be different on the same base. Okay, it is different on the same base. So here, the same thing, planets is one and the same, sun is the same. But two scientists had different imagining power. Okay, wherein Nicolaus Copernicus, what did he do? He just gave out the theory, heliocentric theory, which states that the planets revolve around the sun in a circular orbit, wherein it was turned by John Kepler into the circular orbit into the elliptical orbit. So he told that the planets revolve around the sun, it sweeps elliptical paths, that is, it takes up the elliptical orbit. So this is what we study in a systematic way, and as days pass by, as year pass by, there is different imagination or different practical or theories given, or the practical way it is proved and confirmation is given. Each and every time different analysis has been taking place, and different answers or different view is been coming forward. Okay, so there is nothing like, oh, it is the end. Nothing like there is an end for science, end for understanding. Okay, it is that continuously we just go on analyzing things where even a minute particle can give a complete change for a theory. Okay, so next is coming to physics. You got to know science is to know, and science includes branches. There can be physical science as well as biological science. Biological science, there you are studying the behavior of living things, where in case of physical science, it is divided into physics as well as chemistry, wherein you will be studying the behavior of non-living things. The behavior of non-living things around the world. Okay, so which is very interesting. How the biology living things, studying of the living things is interesting. Similarly, if you understand regarding non-living things, that is also very much interesting, because you will get to know certain facts which you don't know. And knowing the facts, you can just work on even more and you will reach out somewhere else, right? So here, physics. Coming to physics. What is that physics? From where did that term physics come? Physics. It's your favorite subject, right? So physics has come from a word called as fuses. Okay? Fuses is the name from which the name called as physics originated. So what is meant by that fuses? Fuses is a Greek word which means nature. You're studying about nature, right? Nature includes what? Non-living things. Yes. So studying complete mechanism, operation or detail about it from the basic. So that is, everything is included in nature, right? So study of fuses is nothing but physics. Study of nature. Since fuses is a Greek word, and from that Greek word we have got the name as physics. But in Sanskrit, it is called as Bhautiki. Okay, in Sanskrit, its name is Bhautiki. So here you are studying complete things about the nature. In this picture itself, you can just completely visualize certain things. It includes almost all the pictures which occur in nature. Very interesting facts which you want to understand, which you want to know. Okay, so science, right? Okay, so the next thing which I'm going to, let us go to the next slide, that is physics. When it comes to physics, you will have to understand one, unification as well as reduction. Unification and reduction. So you know what is unification and reduction? Unifying things. Unifying. Unicorn. You know unicorn, right? Unicorn is like it's having a single horn, right? So it is unicorn. Okay. So here, unification, that is unifying. Single. Okay. Complex terms, many terms will be, number of terms will be there. It is unified. It is brought together into a single term, that is called as unification. Electricity is different. Concepts like electricity is different. Okay. And concepts like magnetic field is different. Concepts of light is different. So there are bits of terms, electricity, magnetism, light, like that, right? So it is been unified into one theory, that is electromagnetic theory. So here the different concepts are brought together into one single theory, that is the theory is being unified to a electromagnetic theory. So here it is unified, unification is being done here. Next comes to reduction. So what is that? Reduction, reducing a complex one into simpler terms. Okay, here bits and pieces are unified into one single thing. Unification, fusion is taking place, whereas reduction, here the fission is taking place. So here a bulk is split into too many parts. Okay, a bulk is split into too many parts. So here physics consists of unification as well as reduction. Either you can unify the terms or else you can reduce the terms. Okay, next it is development of theory leads to new discoveries. Okay, developing theories. There are many other scientists who have developed too many theories which has led to new discoveries. Okay, so now for example, let's take J.C. Maxwell. He has introduced a theory. He gave out the theory of electromagnetism. Just he gave the theory of electromagnetism, which was taken and practically it was approved. Practically it was confirmed. So it was taken by who practically confirmed So here it was just theory. When it came here, it was practical, right? So it is the systematic study. First theory is done, then practical thing is done. So here theory led to new discoveries. Okay, discoveries with the practical work called as experiments. So experiments was undertaken. The theory, practical is nothing but experiments, conducting experiment based on the theory or the basis of theory. Okay, so here this is one of the example which I am telling you. Even Pauli Dirac, he introduced a theory. He gave a theory of antiparticle. Later it was taken by Carl Anderson. Later in his experiment, he gave a new existence to a positron. He found out a positron. Okay, that is the thing. Like you are giving theory, and while doing a practical, that is when conducting an experiment, there is something other new discovery. Okay, then theory exists of that discovery, and then again you go with the experiments, and then you find a new thing. Okay, so there is no end to know. There is no end to know. Okay, you have to remember there is no end to know. Okay, this is the concept actually. There is no end to know. You have lots and lots to study, lots and lots to know. Okay, so science never has an end. Okay, so here you got to know because of the discoveries, because of some other theory, you're discovering some other elements, some other atoms, or some other new phenomena in nature or in the world. Okay. Next is this physics. Physics consists of many branches are there, out of which only few branches I am discussing over here. That is mechanics, thermodynamics, electrodynamics, atomic and nuclear physics. Mechanical physics, thermodynamical physics, again electrodynamics and atomic physics and nuclear physics. So coming to mechanics. Here in this mechanics, it involves everything about laws of motion, complete natural phenomena which has been undertaken over here, work, power, the work, mechanics. It's a work taken by the object, what work it does, okay, how it does, the complete mechanism of an object like this mechanics include. And coming to thermodynamics, it includes temperature, regarding the temperature of the gases or the temperature of any other substances, pressure, volume of the gases. In such way, this is a study of temperature. Next, coming to electrodynamics. So what does this electrodynamics include? Here in this electrodynamics, electricity, magnetism, behavior of electricity as well as magnetism on whole, all those things comes under this electromagnetism. So there is much and much to know. This is just a skeleton of that which I am telling you, but there are deeper as you go. There are much and much to learn, and each and every topic, no, it's very much interesting, and you will be like, you have to learn even more regarding that topic. So it is very much interesting. But remember students, before starting up, you will have to take up each and everything seriously. Hard work is very much important, and you will have to know what are the concepts you're supposed to study and go in detail, okay, of the concept. Okay, next is atomic and nuclear theory. Atomic and nuclear theory. Here you're studying regarding nuclear bombs like fission, fusion reactions, atoms, molecules, nuclei, protons, neutrons, and all these stuff you'll be studying in atomic and nuclear physics. So that is what you study in this physics. It's very interesting. Just go look at this image. Like, don't you feel the images are interesting? Don't you feel like studying something? Even a matchstick. There is something, some chemical reactions, there is physical reactions, everything which is taking place over there. So it's very much interesting. Even the steps which you put, like you walk, right? So there is also physics. The technology, everything has got physics in it, okay? So if you observe, each and everything in this world is made out of physics. You can find physics in each and every object of yours. You can study physics, you can find physics within yourself as well. Okay. So next, so study of thermodynamics. What did it do? Okay. It's like it led to the invention of steam engine. Studying electrodynamics. What did we get? There was the invention of wireless communication. Okay, and discovery of neutron-induced fission reaction, which comes under atomic and nuclear physics. Okay, so discovery of this neutron-induced fission, it acted as a basic component. Okay, it acted as a basic component for reactors. And next is study of photoelectric effect. Coming to study of photoelectric effect, you know, radiations. Okay, black body absorbs radiations. You have studied that in your earlier classes, that black body is absorbs heat. So it absorbs radiation, it absorbs all kind of radiation. So what kind of radiation it absorbs? Okay, it absorbs all kind of radiations. Because of that radiations, which it can be converted into something. So heat energy can be converted into light energy, right? So that is the thing which you study here. By understanding the photoelectric effect, complete photocell working, that is conversion of heat energy into electrical energy, was studied. So in study of thermodynamics, there is some concepts which have come into existence, and even now there are many other stuffs which have come into existence, instruments or some other things. Okay, like that. Similarly, that basic laws of, if you're studying basic laws of electricity, there is technically we are developing even more, right? Technology, everything has a base. That base is nothing but study of physics, the basic laws, everything. Okay, and even the astronomy also, it is very much interesting. That comes the astrophysics. So even more deeper and deeper when you go, you will get to have the knowledge regarding it. Next, coming to fundamental forces. So there are 4 fundamental forces in nature which we are studying. That is, one is strong nuclear force, another one is weak nuclear force, then gravitational force, then electromagnetic force. So there are 4 fundamental forces, that is gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Coming to the gravitational force. So as you all know, gravity, we experience gravity. Above certain level, we just don't find any gravity. Astronomers you see, or you go up in the rockets, you just see floating, right? So there is no gravity there. Okay, so it is gravitational force here in the earth. Each and every object attracts every other object in the universe. Okay, even I am attracting certain objects around me and you people are attracting certain objects around you. So it is like we are attracting each and every object around us. So every object attracts every other objects in the universe. Okay, so that is known as gravitational force. There exists certain force that is known as gravitational force, and weight depends on gravitational force, but mass doesn't depend on the gravitational force. This you will study later in your later chapter of gravitation. Okay, so coming to the next is electromagnetic force. As you all know, electrical field is different, magnetic field is different. Together it is combined to electromagnetism, electromagnetic effect, right? When there is 2 charges, if you are considering 2 charges, let me consider one charge as Q1 and another charge as Q2. So there are 2 charges, Q1 as well as Q2. Okay, so between these charges, there exists the electric field. When there is existence of electric field, there is existence of magnetic field as well. It is a natural phenomena which occurs when there is a presence of electric field also. Okay, so there is certain force between 2 charges. Okay, that force is nothing but electromagnetic force, which is given over here. And when the charges are at rest, the electromagnetic force can be given by Coulomb's law. That is, electric force is directly proportional to product of 2 charges and inversely proportional to square of the distance between them, which is where this proportionality term is cancelled to equal to, and constant is given, Coulomb's constant Q1 Q2 divided by R square, which is called as Coulomb's law. Okay, that applies to this electromagnetic force. Next is strong nuclear force. Strong nuclear force occurs up to 2 Fermi. So what is this Fermi? It is 10 raised to minus 15 meter. Okay, Fermi means the value of Fermi is 10 raised to minus 15 meter. So it is strong nuclear force occur there. Okay, protons as well as neutrons, or neutrons as well as protons, or protons and protons. Any 2 interacting particles distance can go up to 2 Fermi. Maximum it can go up to 2 Fermi. Above that, if it goes, it is like the force between them decreases, starts decreasing. So it is not applicable for strong nuclear forces. So the distance between 2 interacting particles, maximum it can go up to 2 Fermi. Okay, so it is the distance, the force of attraction is there, no, that is nothing but a strong nuclear force. That is known as short range force. Okay, it is the strongest force in nature. This is the strongest force in nature. Strong nuclear force is the strongest force in nature, and it is a short range force. As the distance increases, it becomes weaker. So what is this weak nuclear force? Is it that as the distance increases, it becomes weaker, so it is called as weak nuclear force? No. Weak nuclear force that occurs only in beta decay. Okay, during beta decay, it is converted to positron, whereas you will be having emission of electron and antiparticle. Okay, so during that beta decay, the force which is observed is weak nuclear force. So this is all about fundamental forces. So there are 4 fundamental forces. They are gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. You all know gravitational forces. Each and every object attracts every other objects in the universe. So that is gravitational force. You will study in much detail in your next coming chapter, that is gravitation. There is a chapter called as gravitation. So in that complete in detail you will get to know. Okay, so that is gravitational force. Another one is electromagnetic force, which acts between the charges. And next is it is strong nuclear force, which acts between 2 interacting particles. And next is weak nuclear force. So is this in an order? No. There is a decreased order. That is, firstly I'll be telling regarding the high force, that is the strongest force, and as a strongest force in nature, and then I'll give a decreased format. So first strongest force in nature is strong nuclear force. Then comes electromagnetic forces, and then it is all about weak nuclear force, and lastly it is gravitational force. So this is the sequence of the fundamental force. So until now, what and all we have studied? We have studied regarding the science, what is physics, and discoveries and inventions. Certain examples we have taken, and physics consists of mechanics, certain branches I have discussed, not all the branches, mechanics, thermodynamics, electrodynamics, atomic and nuclear physics, astrophysics also. Next is fundamental forces, where 4 forces, fundamental forces you have studied. This is very much important for you to know all 4 fundamental forces. One is gravitational force, strong nuclear force, weak nuclear force, and electromagnetic force. Possibly 1 mark question is asked from this. Okay, so you will have to, the weightage of this physical world chapter is 2 marks. Each 1 mark is very much necessary for you to score centum, as I told you. So focus on all the forces, all the points, each and every point which I am discussing over here. Okay. So next is conservation laws. So what is this conservation? Conserved. Okay. So there only you get conserved quantities. So what is that conserved quantities? You are conserving something. So conserved quantities are the physical quantities which are not changing. Okay. Which doesn't change in certain process. If the certain process have undergone, there is no change in its physical quantity. Okay, so those quantities are called as conserved quantities. So what are these conserved quantities? The physical quantities which remain unchanged after a physical process is said to be conserved quantities. And the law, certain laws are given for that physical quantities, and the law which governs the conserved quantities are called as conservation laws. The law which governs these quantities, that is physical quantities which are unchanged, conserved quantities, are called as conservation laws. So there are few conservation laws which I have given here. Law of conservation of linear momentum, law of conservation of angular momentum, law of conservation of total energy, conservation of mass, and conservation of electric charge. So law of conservation of linear momentum, here in this we study regarding the interacting particles, about interacting particles. Okay, law of conservation of linear momentum, we study regarding the interacting particles in the absence of external field. Next, Law of conservation of angular momentum. Here we study regarding the rotating bodies. Here it is all about rotating bodies in the absence of external torque. And law of conservation of total energy. Okay, here we study law of conservation of total energy. That is another conservation law. Fourth one, it is conservation of mass. Okay, here this law of conservation of total energy, it applies to all, and conservation of mass. Okay, this conservation of mass, it is for any chemical process or any chemical reaction. So when it comes to conservation of electric charge, it is regarding the electric charge. Okay, so these are the conservation laws. So the conserved quantities are the quantities which remains the same even after it remains unchanged in a physical process. So those quantities are called as conserved quantities, and the law which govern these quantities is called as conservation laws. So here there are 5 conservation laws which I have mentioned over here. Law of conservation of linear momentum, conservation of angular momentum, conservation of total energy, conservation of mass, as well as conservation of electric charge. These are the conservation laws. So in this science and physics, you have studied regarding, you got to know like discoveries led to invention of many other things. So here there are too many discoveries and scientists' name which is available in your textbook as well. And here are few names which I have mentioned over here. You can just go through it and analyze things. Okay, Archimedes, his discovery was principle of buoyancy as well as lever. If you go like how they discovered all these things, it's very much interesting. So if you want to know any of the theory behind it, like how they discovered, you can just Google it and you can just check it out like how it exists. Okay, in the next class I keep explaining regarding things and regarding discoveries. In each sessions of mine there will be explanation of each discoveries, okay, for you people to understand it better. Okay, so Archimedes, it's principle of buoyancy, principle of lever. Galileo Galilei, law of inertia and telescope. Then it is Isaac Newton, law of mechanics and gravitation. Then when it comes to Heinrich Hertz, radio waves and photoelectric effect. J.J. Thomson for electrons. Like similarly, there are many other important discoveries which has been taken up from certain scientists. And in today's class of ours, what and all we have studied? We have studied what is meant by science, and science consists of branches called as biological science as well as physical science. 2 branches, that is physics as well as chemistry. And here I'm a faculty of physics teaching you people physics. So coming to the physics, what is meant by physics? It's a term, it has come from a Greek word called as physis. And what is physis? It is nature. So study of nature, right? Okay, and certain laws and fundamental forces and certain theory led to the discovery of, while doing practicals, it led to new discoveries. Okay, and that is known as experiments. So you got to know what are experiments, what are theory things, and it has got no end to know. You got to know that concept as well. So there are certain things which you have studied over here, and conservation laws and what is meant by conserved quantities as well. And even certain scientists' names have been put up in the table, and you had studied which scientist discovered which event. Okay, those things are there in detail. In each and every classes, one scientist name I'll be taking up, and I'll be telling out discoveries of them. Okay, that is the interesting fact which will be going on in next session of ours. So here completes the first chapter, that is physical world. So next is units and measurement. That's the second chapter. Until then, have a good day. Thank you one and all.